Welcome to my YouTube channel. Today we'll be discussing about wave. Now this topic is very broad. So we're talking about wave, how to calculate wave, progressive wave, stationary wave. We'll talk about different type of wave, light wave, sound wave, and so on and so forth. So the very important thing before we dive into calculation is to actually know each term. What is this term saying? When I say a question like this, how do I answer them? So that's what I want to treat in this video today. First of all, what is wave? Now there are four things we need to consider when we want to know the definition of a wave. If I take a stone and throw it to cause a ripple wrong in a river, that ripple, those circular stuff, that is a wave. You're hearing me because of wave. A person playing a guitar, when it strikes the string, it vibrates and you hear the sound. That is a wave. So what is a wave? Now if I take my guitar and I plug the string, the string was initially at rest. So when I plug it, I'm disturbing it. When you throw a stone into a river, you are disturbing the peace of the river. So the first thing about a wave is it is a disturbance. The second thing, which travels through a medium. If I'm playing my guitar, the string is the medium. Okay? Transferring energy from one point to another. If I plug the string of my guitar, I can feel the vibration here. I can feel the vibration at this fret, and at end of the fret, I can feel the vibration. So it is transferring energy. If you throw a stone into a river, you discover that the ripple that is made is continuous till it gets to a point, then it stops. So it transfers energy from one point to another without causing any permanent displacement of the medium. So it means when I plug the string of my guitar, it vibrates, it transfers energy from one point to another, but the string of the guitar is still intact without causing any permanent displacement of the medium. It means at the point it's going to stop. When you throw a stone into a river, it's caused a ripple. At a point, it's going to stop. The water will disappear. So, what is a wave? A wave is a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Now, let's look at terms used in wave. Amplitude. Amplitude, this is the maximum displacement of the particle of the wave from its mean or equilibrium position. It is measured in meter. Now I have a pictorial view of a wave, and this is a sinusoidal wave. The wave here is a sinusoidal wave. It's a sine graph. So from that definition, where is the amplitude? It is the maximum displacement of the particle. This y-axis is the displacement. This horizontal can be x or t, can be distance or length or time. We're going to understand that later. Now, this is the maximum displacement. So, at this point, it's at equilibrium, or at this point, it's at mean. Where is the maximum displacement? This is the maximum displacement. So this is amplitude. This is the amplitude. Let's continue. It is measured in meter. B, wavelength. This is the distance between two successive trough or two successive crests. Now the question is, where is the trough, where is the crest? At this part, the positive side is the crest. The negative side is the truth. This side is the negative side. This is the positive side. So the distance is the distance between two successive strokes or two successive crests. It is also the distance covered by wave when it completes one circle vibration or oscillation. At this junction, I want you to pay attention. If I draw a circle and I split it into two, and I decided to separate it, I'm separating it. I've separated it. I have a circle, I split it into two, and I separated it. This two is still a circle. It's still one circle because this is L and this is L. If I decide to split these two, okay, so let me draw it. It looks like this and looks like this. Please, I want you to pay attention to this. If you have the understanding of this, you grab everything that has to do with weight. So this is 1 over 4, 1 over 4, 1 over 4, 1 over 4. The half of half is 1 over 4. Let me see again. So this is a circle. Now a complete circle, the distance covered is what we call wavelength. This is half, I split it into two, and I separated them. So this is half wavelength, 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 wavelength. Now, this is the distance between two successive crests. Now, this is what I'm trying to say. The distance from here to here is a wavelength. It is a what? A wavelength. The distance. This is a wavelength. Or true, from here to here, the distance covered is a wavelength. Okay, let's see how we solve some other question. Now, the distance that is covered when you complete one circle, can you show me the circle? This and this, if you put them together, is a circle. This and this, if you put them together, is a circle. So if I ask you, how many wavelengths are here? You tell me the wavelengths are 2. 1, 2. Do you understand? Then you have, what is the distance from here, from this point to this point? This point to this point. Let me call this point to this point. Okay, let's do it together. The distance from here to here is half wavelength. And this point looks like this, 1 over 4. So this is 1 over 4 lambda. What is 1 over 2 lambda plus 1 over 4? It is 3 over 4 lambda. Lambda is the wavelength. This alphabet in Greek is called lambda. So 3 over 4 lambda. 3 over 4 wavelengths. Let me ask a question. What is the distance from here to this point? From this point to this point. Alright, 1 over 4 lambda. That's correct. That's correct. Okay, let's play a little. Let's play a little. Okay. If I have a graph like this, a sinusoidal wave, how many wavelengths are there? Okay, you can pause the video and try. Okay. 5, 4, 3, 2, 1. Okay, let's count. 1, 2, 3 and a half. So people will decide to count it in half. 1, 2, 3, 4, 5, 6, 7. And say 7 divided by 2 is 3 and a half wavelengths. Whatever way you want to count it, there's no problem. 1 circle, 2 circle, 3 circle and a half. Okay, let me clean this. And many wavelengths are there. Okay, let's go. 1, 2, So it is 2 3/4 wavelength. Please, it is very important you know how to count the wavelength because it helps us solve certain questions. Let's proceed. Period. This is the time for a particle of wave to perform one complete circle or oscillation. It is also the time required by wave to travel one wavelength. So the time taken for a particle to move from here to here is what we call period. Period is in capital letter T. Time is in small letter t. Please take note. Alright. So period is the time taken to cover one wavelength. Okay. Let's proceed. It is measured in seconds. Look at it. Time taken over number of circles. So the time taken here is in seconds. The number of a circle has no unit. So the unit for period is seconds. Let's go to frequency. Frequency now is the reverse. It is the number of circle or oscillation which the wave completes in 1 second. Is the number of circles to complete in 1 second. So what will be the unit? This is a second, right? This is the second. The second is below, so it's going to be per second. The standard is hertz. Now, what is the relationship between period and frequency? It means T is equal to 1 over frequency, or frequency is 1 over period. So, period is the reverse of frequency. Frequency is the reverse of period. It's as simple as that. Let's go to this. The wave, speed, or velocity. This is the length covered by wave per unit time. So, speed or velocity is lambda wavelength over period. Now, I want you to look at something. Look at something. If you look very carefully, we'll discover that velocity actually wavelength times 1 over period. What is 1 over period? 1 over period is frequency. So I can say my speed is lambda f. I prefer calling it f lambda. So the relationship between velocity or the speed, wave speed, and frequency and wavelength is this. The relationship between speed, wavelength, and period is this. Please and please do not mix it up. I prefer knowing this one of heart because I know that f is 1 over period. Okay, so these are the 10 used in wave. In our next video, we're going to do a couple of examples for better understanding. Thank you.